With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so in this question it is given the molar heat of formation of NH4NO3 solid is minus 367.5 kilojoule and those of N2O gas and H2O liquid are plus 81.46 kilojoule and minus 285.78 kilojoule respectively at 25 degrees Celsius and 1 atmospheric pressure. So we have to calculate the delta H and delta U for the reaction, which is NH4NO3 solid gives out N2O plus 2H2. So basically, if you see the values here, I am writing the values of the heat of formation, that is for delta H for NH4NO3, we have a value of minus 367.5 kilojoule. Now, if I write the value of delta H of N2O, that is delta H of N2O, we have a value of plus of 81.46 kilojoule. Now, if I write the value of delta H for H2O, then we have a value of minus 285.78 kilojoule. Now, this is the values that we are given with. So, the delta H for a given reaction, which is this. So we will write our equation, which is, I'm going to write the equation here, which is NH4NO3 solid gives out N2O gas plus 2 moles of H2O, which is in liquid. Now, here you have to listen very carefully that we have only 1 mole of gaseous here, that is gaseous N2O here. So our change of mole will be always 1 for this reaction, because we cannot take the moles of solid and a liquid component in our reaction. And why I am saying this, I am going to tell you later in this question. So first we will find the delta H reaction of this reaction, that is I will find the delta H of the reaction, overall reaction. So we can write here that it is equals to delta H of N2O plus 2 times of delta H of H2O minus delta H of NH4NO3. Now, if I substitute the value here, if I write the values of each term, that is, if I am going to solve this, then it will be given as 81.46 plus 2 times of minus 285.78 and minus of this minus of minus 367.5. So on solving this, we will get a value of minus 122.6 kilojoule. This is the delta H of the reaction here, that is overall delta H of this reaction. Now, in thermodynamics, we have a relation with delta H and delta U, and it is given as delta H is equals to delta U plus delta Ng times RT, where delta Ng change in the gaseous mole in the reaction. So I have told you earlier that in this reaction the change will be 1, because here we have 1 mole of the N2O gas and the rest of the components are liquid. So if I put the value of this in this equation, then we will find out that minus 122.6 into 1000 equals to delta times U plus 1 times 8.314 times 298, that is our temperature, which is given as 25 degrees Celsius. So if I convert it into Kelvin, it will be 298. Now, if I solve this equation, if I just take this out and if I write the delta U of the reaction, it will be the minus times of 122.6 into 1000 and minus times of this value, and this value will come around 2477.5 72. So if I going to solve this equation, we will get the delta U as minus 125.07 kilojoule. Or if I just rounding off it, we will get minus 125.1 kilojoule. That is our delta U of the reaction. So in this way it is calculated. So our answer is the delta H value will be equals to minus 122.6 kilojoule and the delta U of the reaction will equal to minus 125.1 kilojoule. So in this way this question will be solved, and I hope you get the concept.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.